Hi everyone, it's Coach Fred here, and today I'm going to be going over finding the zeros by factoring, finding the zeros of polynomials by factoring. Now, it is very possible that the way I factor this today is not the way you've been taught, and that's okay. Today I'm going to be using a method called the reverse box method. Some teachers teach using the reverse box method for factoring, so that's what this video is going to use. If you factor just by finding the sum product, then I will make that video as well, and you'd want to look for that, okay? But today I'm going to be finding the zeros by factoring. All right, so looking at this first one, I want to look at it and see the polynomial has a degree 4. Why? Well, that tells me that the fundamental theorem of algebra tells me I'm going to have 4 roots. Now, they don't all have to be real roots, but I'm going to have 4 roots. So that always helps me that I'm going to have 4 answers when I solve this by factoring. Okay, so the first thing we want to do if we're going to solve by factoring, this is a function. We need to make it an equation that we can solve. So we're going to let y equals 0 and then solve by factoring. Now, regardless of the method you use, you know that we're looking for things that multiply to 6 or factors of 6 that add to -5. All right, so the reverse box method is, it's really a reverse of the area model. And so I'm going to use that. So I know that I want an x to the 4th in this box, and I know that I want a 6 in this box. Well, to get an x to the 4th using multiplication, it would be x squared and x squared, okay? So I know I'm going to have an x squared in this box, and I'm going to have an x squared in this box. All right, but I need them to numbers that will multiply to a 6, a positive 6, but they will add to a -5. So add, multiply. So that would be -3 and -2. And so if I do that, it would look like this. And those two together do add to -5x. All right, so then I've factored it. My factors would be x squared minus 3 and x squared minus 2. Now that you have it in factored form, you want to use the zero product property, the zero product property. The zero product property says that you take each factor, you set it equal to 0, and then you solve. So x squared minus 3 equals 0, and x squared minus 2 equals 0. So I'm going to add 3 to both sides. That's going to give me x squared equals 3. I'm actually going to get this out of the way because it is in my way now. And then I'm going to take the square root of both sides. Now, we've got to be really careful here because remember, when we take the square root of x squared, we have to consider both the positive and negative root 3 because it's really taking the absolute value. And when we bring the 2 over, we're going to do the same thing, take the square root, and so we get x equals plus or minus 2. So my zeros would be root 3 comma 0, negative root 3 comma 0. So remember that zeros are coordinate points. They are the x-intercepts in this case. Root 2 comma 0 and negative root 2 comma 0. So those are my zeros, and I solved them by factoring. And I need 4 of them, right? Based on that fundamental theorem of algebra. All right, the next one takes it a step further. Again, we want to set y equal to 0, and then we solve by factoring. But really, one of the most important steps in factoring is to look for a greatest common factor first. And I noticed that all of these have a greatest common factor of x. So I'm going to factor out the x first. That's going to leave me with x squared minus 8x plus 16. Now I have to keep factoring because I've got this trinomial. All right, so I'm going to go back to that reverse box method. Make it a little bigger so you can see it. And I know that I want an x squared and a 16. Some of you might recognize this as a perfect square trinomial, which it is. So the factors that add to a positive 16 that add to -8 would be -4 and -4. So in factored form, I have 2 of the exact same factors. So that's can either raise it to a power 2 or write them separately. All right, now we use that zero product property, and we set each factor, including that x that's outside, equal to 0. Okay, all right, so x equals 4 and x equals 0 are my two x-intercepts. But you might say, wait, Coach Fred, that has a power 3, I need 3. roots. Well, this one right here, because it's raised to a power of 2, remember, that means it has a multiplicity of 2. That means we call this a double root. And that's where on the graph of this function, there's a bounce taking place. So again, that's called a double root. And so I don't want you to panic on that. And that 2 is telling me that, okay? All right, the last one. How's this last one different than the others? Think about that for a second. These both were 3 terms. Okay, 3 terms, 3 terms. This one's 4 terms. So we actually have to do this one a little bit differently. When we have a polynomial of 4 terms and we want to solve by factoring, we're going to factor by grouping. And grouping means take 2 of the factors or 2 of the terms and see if they have a common factor. So I'm actually going to group these guys together and these guys together. And I'm going to take out the greatest common factor. So of the first set, the greatest common factor is x squared. That's going to leave me with x plus 10. And then the greatest common factor for the second set is negative 9, which also leaves me with x plus 10. In order for you to know you've done grouping right, these have to be the same, which is why I had to take out a negative 9. If I just took out a 9, I'd have a problem. All right, now that x plus 10 actually becomes the greatest common factor. So actually, let me get this out of the way so we have some room. Okay, so x plus 10, I'm going to factor it out to the front. And then I'm left with x squared minus 9. Now, you have a couple things you could do. Or you could keep factoring this because that's the difference of 2 squares. Or you could just set each factor equal to 0. I'm going to do that because that's what we've been doing. So you have 2 ways to do that last term there. All right, so I'm going to add 9. And then I'm going to take the square root of both sides. And remembering when I take the square root of both sides, I don't want to forget that I have a positive and a negative 3. And in this one, I'm going to subtract 10, so x equals 10. And again, that fundamental theorem tells me I should have 3 roots or 3 zeros. I do. They happen to all be real. Remember, sometimes we can get complex roots or imaginary roots. So I have negative 10, positive 3, and negative 3 as my zeros. All right, hopefully that was helpful, and have a great day.